computer because that works a little bit better for me. Okay, so we are looking at our review from for the midterm that well, it's not a midterm, not a midterm. It is a mid-year check-in that we are taking in class on Tuesday. It is going to be an hour-long assessment. Well, you're going to get like 80 working minutes, but it's like an hour. It's like situated to be like an hour's worth of content. It will be open note. And I'm going to put together some notes for you guys to like sort of condense everything that we've learned. So don't worry about that. That will be, I'm going to work on that this weekend. So we are working on a review of numbers 1 through 19. So please on your computer, open up the review. If you go to the classroom, I put a link to it. It should take you directly to the link. If it takes you directly there, perfect. I'm hoping it does. So if we look at number 1, we're going to get started right away with number 1. And I'm going to scroll it down. So we were given this set of data, right? And we were also given the 5 number summary. So you didn't even have to do any work, which is pretty cool. So we had to look at this set of data here, and we had to first create a box plot for your data, labeling our box plot carefully and like placing it carefully. So what I did, instead of going through and using these tools, because I showed you how to do this before, I'm going to pull up the picture of what your box plot should look like. So based on your data, I attached this image as well to the assignment. So if you want to look back for number 1, the box and whisker plot picture is here. So if you look at your 5 number summary data, what we did was we drew our box for the box and whisker using that box tool from 61 to 78, because that was our Q1. Our Q1 was 61, where the left side of our box falls. Our right box, right under the box, our Q3 was at 78, okay? Then I used the little drawing tool, and I drew my minimum dot at 60. I drew my maximum dot at 81. And I used a different color to connect, like to make my whisker. And then I drew on my median line at my median value, which was 70. Okay? That was that one there. Okay? So you're not on the actual mid-year check-in, you're not going to have to draw one of these. So don't be like stressed, like, oh, I don't know how to do it. With the tools, because this one isn't going to be necessarily assessed. We're going to be looking at box plots and pulling data out of those. So that was number 1A. Then we had to use that box plot that we created to talk about our measures of center. So if we looked at that box plot, again, if we look back at that box plot, is this a skewed set of data or is it symmetric? Looking at this box plot, is this symmetric? Even, bell-shaped, like same amount on each side of my median. And no, very good. It's not a symmetric set of data. So if it's not a symmetric set of data, what do we use for our measure of center? Skewed data, we use our median value for our measure of center. Very good. It's skewed. Junior said to the right. Very good, Junior. So it's skewed data. So when we're talking about skewed data, just like Peyton, Gabe, and let's see. That's fine. You'll just follow along, Missy, no problem. We say when it's skewed, when one end of our box plot is like one whisker is longer than the other, that's skewed. So that means it is going to be our median. And then which measure of variability goes hand in hand with our median? Because we're going to choose our median here for our data because it's skewed data. We're going to use as our measure of center, is it going to be our interquartile range or our standard deviation? Which one goes hand in hand with a box and whisker plot? And? The interquartile range. Nice job, Abby. Very good, Kyle. Very good. We would say our interquartile range. And we say the reason for that is because when you use median inner quartile range is its buddy. It's its match. It's its soulmate, if you will. Mean goes with standard deviation. The average mean goes with standard deviation. The median goes with our inner quartile range. And it makes sense when we're talking about a box plot, because box plots, we can easily calculate that inner quartile range. We can't easily calculate that standard deviation because we don't have, I mean, if you're just given a box plot, you can't calculate all your specific data points if you're not given them. Good. Let's take a look at number 2. Okay. Number 2, you had to create a histogram. Okay. So this tool was a little bit tricky. So what you had to do here was you had to look at this data here and you had to sort it into 5 categories, right? And I know that this bottom one only went up to 100 and we had some values that were above 100. So we're going to throw all those values that are above 100 in that final category. So when you count these guys out, you look at these guys and the 0 to 20 had 0 values. Okay. 21 to 40 had 4 values. 41 to 60 had 6 values. 61 to 80 had 7. And 81 to 100 had 5. Okay? So if you went through that list, how I did it was I wrote my 5 categories down, and I went through my list and I put a tally for each one and I went down my list. I said 51, put a tally here. 42, put a tally here, or actually here. And you go all the way down your line and put tallies. That is my suggestion if you have to create a histogram. Okay? So then you're going to take these and create your histogram by doing the following. Okay? I inserted a picture of what the histogram should look like. So if you're not able to do it 100% with me right now, that's okay. Yes, but so what I said, Gabe, was because there was no interval for 110 for these values here, I threw them into, we were supposed to throw them into this guy here. Does that make sense, Gabe? Yes, perfect. Thank you. That was a good point, Gabe. Okay, so if I'm going to create this histogram, I'm going to use these values, these frequencies to create my histogram. We scroll down here, and this is probably where the trickiest piece is like you have to hit it perfectly for it to move. So you take your cursor or you move your finger on your trackpad till the little hand pops up, and that's when you'll be able to move it up to 4, okay? You move it till the little hand pops up. You just have to be patient. Up to 6. Move it till your little hand pops up. You go up to 7. Move it for your little hand.
Ms. Kelly, please call extension 3211.
5. Okay. Like I said, on the classroom stream, I inserted a picture of the histogram that's finished. In case you want to go back and look, there will not be a creating histogram question on the quiz. I mean, on the final exam, it got cut. But I wanted to put this on and I wanted to go through it because it might be on the actual final, because the final is everything. So just wanted to go through that for us today, right now. Okay, this is here attached if you need to look at it. Okay, now let's take a look at number 3. This is where it's going to go a little bit quicker. We're looking at this data set here. Okay, we have our summary of our data here. We need to use this summary of this data and this graph to determine, does this data set contain an outlier? Looking at this data set, is there an outlier? Max, what do you think?
Yes.
Wow, yes. Okay, perfect. So he says yes. And which value is going to be that outlier? This is where the tricky part comes in. Which value is going to be the outlier?
50.
And how do you know it's 50 exactly?
Because if you look at the summary statistics, it says that the minimum is 50.
Very good. So when you're given a histogram, hint, hint, hint. When you're given a histogram and you're asked to calculate the outlier, you need to look at the summary data, because then that's the only way you're going to be able to calculate the exact value. Because if you come down here and you say, what's the exact value, and you do 0 to 200, 0 through 200, I'm going to say half credit because I asked you for the exact value. So where you're going to need to look at this statistic summary to get the exact value, because it's usually going to be your minimum or your maximum. So you want to look, see, hey, is it on like the minimum end or is it on the maximum end, and then look for that exact value here. Does that make sense? That's where people got tripped up on the quiz when we took, or the test when we took this unit, was they said, oh, it falls 0 to 200, but I need an exact value by looking at that summary statistics. What's good is, why we do this hand in hand is because this graph here gives us a good representation of a point that falls outside, and then we use our summary statistics to calculate the exact value. Does that make sense? So you got to use both hand in hand. Hand in hand. Can't do both without it. Perfect. Does that make sense, guys? Perfect. Let me know if I'm going, I'm trying not to go too fast, but this stuff, these first few questions are nice, easier ones, and I want to spend a little bit more time on the further in ones. So that, I believe, was all that one asked there. Okay, and then how did you determine it? By looking at my statistics summary. Okay, how did you determine the exact, to be an outlier, it falls outside of my data set, and then I found the exact value by looking at my summary. Okay, I'm not going to expect you to use that formula of like 1.5 times the median towards the interquartile range plus or minus. No, I'm not going to do that. I'm going to ask you just to look at it. Looking at it, it falls outside of my data set. Find it by looking at my statistics summary. Okay. So what we're going to do on this one is I'm going to go through 4, and I'm not going to go through 5 because the questions on the quiz or on the midterm that look like this follow this pattern more closely, where we're looking at 2 box and whiskers, and we need to determine if the statements that are said about them are true or false. So if we scroll it down and we look at our 4 statements here. So this is Angela. I'm just going to write Angela here. Angie. Oh. Okay. So we're talking about Angie and Carl. Okay. And we need to determine if these statements are true or false. So if we look at this first statement here, it says Angie sells more cars than Carl. What do we think? Looking at this box and whiskers, it says generally. So usually when it uses that word generally, we're looking at that interquartile range. Max, what do you think?
I said false.
Why?
Because if you look at Angela's interquartile range and her median, you can see that her median is less than Carl's median, and her interquartile range is also smaller than Carl's.
Good. Also, another piece that we can say for a reason why is because in general, like her minimum is smaller than Carl's as well. So like her data is like equally as, like if I were to shift it over, it would be equally as long, but it's further towards the smaller numbers. So very good. Nice job. That guy is false. Now, the median. Let me see. The median sales for Angela is less than the median sales for Carl. Do we agree with that statement, or is that a false statement? True or false? What do we think? Let's see. Gwen says true. Okay. I happen to agree with that. And because where does our median fall, like geographically, on a box and whisker? If we're looking at a box and whisker and I say, where is my median? Like, if you're telling me, like, geographically, where would it be? On that box and whisker, where would it be? And? Around the middle. But physically, it's going to be this line that falls inside our box. That is our median value. The line that falls inside of our box is our median. Okay? We want to remember that. That line that falls inside our box is our median value. So is Angie's less than Carl's? Yeah, Because if you take Angie's and you pull it down to where it is on here, it's smaller than Carl's. Boom, nice job. Now, the interquartile range IQRs of both salesmen are equal. So are they equally as big of boxes? Looking at them. No. If you're unsure if they're the same, like if it's close, my suggestion, you grab a piece of paper, you mark it off. Angie's is literally the size of my paper. Carl's is bigger, so they're not going to be equal. That is a false statement. Nice job. Now, it is possible, just given these box and whiskers, to determine the total number of sales for Angela is greater than the total number of sales for Carl. Just looking at a box and whisker, can I tell if Angie sold more cars than Carl?
No.
Abby's shaking her head. Why do you think no, Abby?
Because you can't tell by looking at you have to do certain steps to solve and like find out.
Very good. Ian, add on.
It doesn't show, so say Angela could have sold like multiple cars for $30, it doesn't show that on the box and whisker.
Exactly. Nice hand-in-hand work there, guys. This is a false statement because when you're only given a box and whisker, and that's all we're given, we can't pull out our specific data points. Angie could have sold 100 cars. Like, she could have sold a bunch of, like, 1999 Honda Civics. Those are less than, like, the 2 Ferraris that Carl sold. Those are 2 totally different brands. They wouldn't be selling those at the same place, but you get what I'm saying, right? So you can't pull out specific data points from a box and whisker. Like, you can pull out, actually, I take that back. You can pull out 2 data points, the minimum and the maximum. That's it. Boom. Nice job. We're going to skip over 5, and we're going to look at 6. 6 is going to be similar, except we're going to be looking at histograms, I believe. 6, not histograms, dot plots. So we have these 2 dot plots. We're going to look at the statements that we said about these 2 dot plots now. Number 1 says, the mean and median values of hours shown in the dot plots for time spent exercising are the same. So are the mean and the median values for the time they spent exercising the same? Looking at exercising, what can we say about like that shape, that distribution of that dot plot? Max, or Ian, sorry. It's symmetric. It's bell-shaped, it's symmetric, right? So if we have a bell-shaped, nice job, Peyton. If we have a bell-shaped data set, are the mean and the median going to be the same? Think back to what we talked about. When you have a symmetric bell or a symmetric set of data, that means that your mean is going to fall in the middle, your median is going to fall in the middle. When you have a bell-shaped set of data, it is going to be the mean and the median are going to be equal to one another. So this is a true statement because when we have symmetric or bell-shaped, the mean and the median are going to be equal. It's when we have a skewed graph or like a bimodal graph that these things are going to change. Really non-symmetric is going to be when they're going to be different. Okay. Next one, it says standard deviation. The standard deviation shown in the box plot for video games is greater than the standard deviation of exercising. What does standard deviation talk about? So say one of them has a standard deviation of 2. I'm not saying like it matches. I'm just saying we have a standard deviation of 2 and a standard deviation of 17. What does that measure of standard deviation tell me?
How far away data points are away on average from the middle?
Exactly. Very good. The standard deviation basically talks about the variability in our data. How far is the average point away from my mean value, the middle value? The average, really. How far are my data points away from my average value? So the larger the standard deviation, the more what my data is. And spread out. Very good. So, is the video games more spread out than the hours exercising? I mean, like if you're looking at like the numbers that they fall between, they would fall really between the same numbers, right? The range would be the same. But what do we notice? Go ahead.
I was gonna say they're like kind of the same just because they line up with each other, but there is a few that has a lot more values than the rest of them.
Good. Standard deviation is talking about the spread of the data, right? So in this case here, our mean, our average would be like here. In here, and this one, it would be here. So if you're looking at my video games hours, we have more points that are like this point is really far away from my median, my mean. This one, we only have a plus like a 2, like a distance of 2 on either side, right? But this one goes all the way 3 out. So when you're looking at standard deviation, if you have a non-symmetric form or data representation, it's going to have a larger standard deviation. So this guy is actually going to have, go ahead, Ian.
I have a question. Since there's like 2 that's closer to 3, would you count that or would you only count like the max or minimum stuff?
Well, okay, so I just put those 2s there. I was just looking at, in general, like what's the spread, right? So this one on average from my mean, like not on average, but like the furthest out from my mean is 2 on either side. That's what I'm sort of putting those 2s for. This one is like a 3 out. And so you see that there's more of a distance that your points are out. Do you get what I'm saying there?
Yeah, so basically you just look at like the farthest point on that.
Yes. And you're thinking like where statistically would be like my mean, my average, it would be like here-ish because we're skewed this way. And there's more points that are like further out than there are on this guy here. So when you have a non-symmetric graph, that's going to have a higher standard deviation. So I would say for this one, the standard deviation for the games is larger is a true statement. Very good. And I'm going to actually mark that. Okay. Let's take a look at the next one. The median values shown in the box plot for the 2 companies are about the same. So our median values about the same. One second, let me scroll back up so we can look at both of them. What do we think?
Mrs. Crowick, can you please call 4835, Mrs. Crowick?
So if we remember, the median value is when we take, so the mean is when we add them all together and we find the average. The median, if you remember, we line them up, right, from smallest to biggest, and we find the one that like physically falls in the center of that data set. So if we're looking at this data set here, what do we think about that? Are the median values, are they going to be about the same? Or are they going to be different from each other? What do we think? What do we think? What do you think, Max?
I think they're going to be about the same.
And I would say I have to agree with you. Because if we remember, the median value is less likely to be swayed when it's skewed. So because this guy is skewed, it's still going to have a relatively representative median value because medians are not easily swayed by outlying data. Good. Nice job. So they're going to be about the same. Good. They're not going to be exact because we have because it gets slightly pulled one way, but they're very, 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 very close to one another. It's going to be very close in both cases to about 3-ish. Okay, wonderful. Last one. Standard deviation is greater for the video games. What do we think? And very good. Because we have a more spread out set of data on the second one, it's not symmetric. We're going to say that it has a larger standard deviation. Very good. Nice, nice, nice. Fantastic, fantastic, fantastic. We're not going to do, wait, yes, we are. Okay. How would we, looking at these sets of data here, how would you describe this first set of data? Would you describe it skewed left, skewed right, symmetric, uniform, bimodal, or bell-shaped? Abby?
Skewed left,
Skewed left. And why did you say left?
because most of the data is on the right.
Very good. We talk about skew in opposites. If more of our data is on the right, we're going to say it's skewed to the left. If more is on the left, we're going to say it's skewed to the right. Good. Now, that was the only one to apply for this one here. What do we think about the second one here? What do we think? Hi, Tyler. We're in the review. What do we think about for the second one here? Adam? Skewed to the right. Very good. Nice job, Gwen, Peyton, and Junior. Very good. Because we talk about skew in opposites, right? If it's more data on the left, it's skewed to the right. This guy is not symmetric. It's because we're not like, if I fold it in half, it's not going to like fit nicely. It's not uniform. We don't have all the same values. It's not bell-shaped because like bell-shapes, the peak is in the center, right? Not a no-go. And it's not, oh, I can't remember what the last one was. Let me scroll up. Bimodal, that was good. It's not bimodal because there's only one peak. Good. Good catch there, Max. Thank you for that. So we said this guy was skewed left, skewed right. This guy here, there are two that I would choose for this one. Two that I'm going to collect for this one. What's one of them, Cam?
Symmetric,
Good. Why do you say symmetric?
because if you fold it in half, it'll be the same.
Very good. If you fold it in half, it would be the same. And then Sadie said the other one was uniform because we have all the same values. Like in this case, we have all the same values. Good. Nice job. Two for that guy. As we look at this one here, I'm going to have to scroll it over a little bit. So let's look at it. What are some terms that we would use to describe this one? Or maybe even just one term. What do we think? Adam? Bimodal. Good. Is there any other one that we would say?
I might say skewed left because there's more data on the right. Or it looks to me there's more data on the right.
Okay. I would accept that one for this because there is more data physically on the right. I would accept that, or so it would be skewed left. I would accept that. I would say it's not the best descriptor, but it is accurate based on this data here. Good. I do have a peak on the left, but it's minimal. I mean, there's less data there. So I would override that, and I'd probably accept that as an answer as well, because it's not the best. I mean, it's not the clearest. Good. Now we're simplifying equations. So I have this guy here. This section is where you're going to start to do some things on paper. I have a 2 parentheses 5x, negative 2 parentheses 5x minus 6. What do I have to do here to simplify? Go ahead.
Multiply everything inside the parenthesis with negative 2.
Okay. Is there a special math word that we call that? Ian? Distribute. Very good. Negative 10x plus 12. Boom. That is what I'm looking for. You're not able to solve for x because it's not equal to something. It's just an expression. So this would be our final answer for this one. Good. I'm going to move forward, but I'm going to leave this up here. I'm going to leave it up here. Okay. Next one is the same thing. What did you have to do here? I'm not going to do it out, but what did you have to do before to sort of simplify this, make it more condensed? Nobody at home knows? You guys put it in the chat if you'd like. What do we think? Ian, help me out. Very good. We have to combine our like terms. 3.5x and 5x combine to an 8.5x. and a 4 and a negative 11 combine to a negative 7. Boom. Now, this is where it's going to get a little bit trickier. And this is where I want to spend a little bit of time. So let's take a look at some of these solving guys. Okay. Nice job, Gabe. Perfect. We're looking at these guys here. 10 has 5 equations that you need to solve for x. Looking at the first one, what do? What am I going to have to do to get the x by itself? First thing, Max.
Subtract 22 from both sides.
Very good. Because I need to get this x by itself, so I need to subtract 22 on each side. I'm going to get a negative x is equal to, oh goodness, Mr. Rain, 6. I'm done. I'm done. X is equal to 6. Max?
You have to multiply both sides by -1.
Good. We'd have to either multiply both sides by -1 or divide. Very good. So you could say, I showed it to us as divide by -1, divide by -1. So then you would get x is equal to 6, -6. You could also write it as negative x is equal to 6 times -1 times -1 to cancel out your negatives that way and be left with your x is equal to -6. That means the same thing. So I know that I've presented it as divide by -1, but if multiplying by -1 makes more sense, do it. Okay? Nice job there, Gwen. Fantastic work. Let's take a look at the next one. Okay? It says solve each of the following equations. Show your work on the scratch pad, but I'm not going to have you do it on scratch pad. You're going to do it on paper and then take pictures. So you have this guy here. I have 8. What do I have to do first before I can start to move things? Look at it on your screen or look up here. What do I have to do first before I can start to do things? And
Combine like terms. So add to 7n plus 10n.
very good. So I have an 8n plus 12 is equal to a 7n and a regular n is how many? 8n. And then minus 14. Very good. Do I have to do any, I'm looking at this. Now I can start to do something. I'm looking at this. What do I notice? Don't get ahead of yourself, Gabe. What do we notice? This is where yesterday on one of them, a lot of people fell down. What do we notice when we look at these equations? Nice job, Peyton. Nice job, Gabe. Nice job, Junior. So we added them together. Abby.
They have the same slope with different constants.
Oh my gosh. Same slope. Different constants. I don't even need to do any work. What's my solution going to be? No solutions. On your midterm, there's going to be one of the solving ones that's going to have either infinitely many or no solutions. You need to be math detectives. You need to be critical math people because you need to look at these things before you start just going through. Because if you were to keep going with this, you would get minus 8n. You would have canceled out 12 is equal to negative 14. And what does that show you? Nothing. So no number would work there. So if you, let me pose it to you this way. If you aren't if you don't critically look at it and you go through and you solve it and you get some number is equal to some number, you can automatically make that designation of, if you cancel out your x's and you're left with two different numbers on each side, you can say no solutions. Okay? If you go through and you're not a critical looker adder, not a really good way to say it, but if you were to go through and you're not critical and you get 0 is equal to 0, this one would be infinitely many solutions. Okay? So if you go through and you solve it and you get some number, you cancel out your variables, you get some number is equal to some number, two different numbers, no solutions. If you go through and you solve it and you get 0 is equal to 0, you designate that as infinitely many solutions. This is where yesterday, that piece, a lot of people fell down. A lot of people looked at that system and said, oh, hey, solved it, you got 0 equals 0, you put it in the coordinate pair as 0, 0. No, we want to designate it 0 equals 0 means infinitely many solutions. Okay? Good. Now for C, what would I have to do for C to solve that one? Do first, Ian.
Get that by itself by adding 2 to both sides.
Add 2 to each side. 10 is equal to 3/4 x. Two things I can do here. What's one of the ways I can get that x by itself? Do what to it? Let's see if people said on the other thing. Not divide by 3/4. Why would you divide by a fraction? Don't divide by fractions. What can we do instead of dividing by a fraction? We can multiply by what? The reciprocal. Multiply each side by 4/3. 4/3. 40/3. Not 30. Yes, give me 1 second, Peyton. And then 3, right? So you could multiply by the reciprocal and get 40/3 is equal to x. Or another way that you could do this, let me show you. You get 3/4 x is equal to 10. You could break it apart and do it two separate ways. You could first multiply by 4 on both sides to cancel out that denominator, be left with a 3x is equal to 40, and then divide by 3 to get the x by itself. Do you see that, Peyton? Both ways would, yes. Do you see what I just did there, Peyton? Perfect. So, perfect. That's good, Junior. And here's the deal. Being a math detective, you and your friend might do it two different ways because you see it two different ways. I am not simply saying you have to do it this way or you have to do it this way. You have to be flexible and you have to be aware of your abilities and say, I need to break it up into first multiply, then divide. Or I need to do it just multiply by that reciprocal. You make the decision. I'm not saying you have to do it one way or the other. I'm saying, did you get the right answer? And then were the steps that you took logical? Did they maintain equity? Good. Last, this one down here. Ooh, this one's not too bad. I like this one. It's a fun method that we can use to solve this guy. We can, on this guy, cross multiply. Multiply numerator by opposite denominator, numerator by opposite denominator. 7 times, oh, I wrote over the line so I couldn't really see it. 7 parentheses n plus 1 is equal to 10 parentheses n minus 1. Okay, distribute here. I'm going to sort of just go through it. 7n plus 7 is equal to 10n minus 10. Okay, and then minus 7n. I chose minus 7n because the 7n is smaller. Being strategic about it, minus 7n. Cancel. 7 is equal to 3n minus 10. Okay. And then to get this x by the n by itself, I would add 10 to each side. 17 is equal to 3n. How do I get my n by itself? Divide by 3 on each side. Yes, very good. I have a prime number here. I would suggest to you writing your final solution as a fraction, because sometimes, yes, good job, Peyton. Sometimes we round things incorrectly, and so I have to take off like point, like half a point or something. So I would say, if you do it and you get like a fraction, like this guy here, leave it. Just type it in here as 17, and then hit the divide button, and then 3. And if it doesn't take it as an answer, I will override it. If you do it as a decimal, I would say round it to the nearest hundredth, but like I wouldn't do it because fractions and decimals are a little bit tricky. Okay. Last one down here. There's 2 methods that we can go about solving this with. I'm not going to solve this one for E. For E, there's 2 methods that I can do to get to first step. What do you think, looking at letter E, what would be your first step to solve this? Take 20 seconds looking at it on your screen or up on my screen. What would be your first step? Nice job, Peyton. I'm going to give you another 10 seconds. Nice. Good job, Junior. This is where we're coming in and we're getting different first steps. If we do it strategically, maintain equity, we will still get the same answer. Abby, what were you thinking for the first step here?
I would distribute the 1/5 to the 5x plus 1.
Okay. So Abby said that her first move would be distribute. So she said her move would be distribute. So that means multiply the 1/5 times the 5, 1/5 times the 20. Peyton gave me another move that we could do here. What did you think another move could be, Ian?
You can divide by the reciprocal.
Divide or multiply by the reciprocal. Good. But if we multiply by the reciprocal, we would multiply each piece individually. So let me show you what that would look like. So if I have, let me just write it. Give me 1 second. 1/5 5x plus 20, 4x minus 5. So you would multiply by the reciprocal of like 5/1, right? Multiply, so that's equal to 5. So I would multiply this by 5, multiply this by 5. If you multiply by the reciprocal, you multiply each piece individually. Good. So then you would get 5x plus 20 is equal to 20x minus 25. There we go. And then if you were to distribute, it would make it a lot smaller because we're multiplying by a fraction. It would be like x plus 4 equals 4x minus 5. It is all up to you. You are the math detective. You are the leader of your own assessment. You pick a step that you feel more, very good, you feel more comfortable with. If you see that fraction, you're like, I hate multiplying by fractions. Multiply by the reciprocal then. Get rid of it by that way. If you feel like I'm real good at distributing, do it. It's up to you. You will get the same answer no matter how you go through it. Okay? Okay? Now, we're looking at 11. Write an equation for the amount of money in his account based on the number of weeks he has purchased snacks and school supplies. So let's read the story. John has $45 in his bank account. He spends $6.25 per week on snacks from the vending machine and $2.50 per week on school supplies. On the drinks in the school supply, in the vending machine. He spends $6.25 on snacks, $2.50 on drinks. He has a total of $45. What kind of form is our equation? If we're going to have two different variables here, and because we're going to have snacks and we're going to have drinks, what form are we going to write this equation in? Slope-intercept form or standard form? Remember, slope-intercept is like when you have y equals. But we say we're not going to be y equals this time. He only has $45 that he can spend. So it's not going to be y is equal to, it's going to be 45 is equal to, and then we have to look at the number of snacks and the number of drinks that he buys, or the number of weeks that he's buying these things. So if we look at this and we say we have $45 in our account, okay? Each week he spends $6.25 on snacks plus his $2.50 for every drink, right? So, question, go ahead.
For this one, I put the same variable for both of them. I put W for both of them since it said that based on the number of weeks, and it says that he spends that much per week.
Yes, that would, the only place where that could come into a problem is if we say later on down here, we put forth this idea of he's buying different number of, so he's going to buy snacks. He's definitely going to buy snacks for 6 weeks. How many weeks can he buy drinks for with the remaining money? So we want to, the reason that we're going to want to make this into two separate variables is because later on, we're going to be looking and using different numbers for each of them. You know what I mean? Because it's not always going to be, you're buying snacks for 3 weeks. Can he do it? Yes or no. It's going to be, sometimes he buys 6 snacks. How many can he buy with the remaining? So that's why we would break this into two sort of variables. Do you guys see? Or yes, Kyle Kelly, that's good. You can use X and Y on that. That's fine. I just used S and D because we're talking about snacks and drinks. Once again, I'm going to say, if the variables you use X and Y, or if you choose to do S and D, you're still going to get full credit either way. Okay. Let's take a look at the next piece. So if there's 12 weeks in the first quarter of school, can he continue to spend the same amount per week for the entire quarter? So that means this time, just so happens, we're plugging 12 in for the S and the D because we're buying 12 weeks worth of snacks and we need to decide, is that a true statement? So if we do, that would be like plugging 12 in for each one of these variables here. Is 45 equal to 625 times 12 plus 250 times 12? Okay, that's what we're looking at for that one there. So if I go through and I do my multiplication, I have it written down here. This is number 11, right? Because when you plug it in, you get 625 times 12. Sorry, I didn't write this down. You get 75. So you automatically don't have enough money. So can he do this? No way, Jose. He doesn't have enough money. For the reason why I plugged 12 in for each of my variables, and he didn't have enough money. He spent too much money. That's all I'm looking for here. I plugged it in, and it wasn't a true solution. It wasn't a true equation. 45 does not equal however much that adds up to. Did you see what I'm doing there? Good. So for the explains, you're just saying like, I plugged it in and solved. Okay? Next one, this is why we needed to write it with two different equations, or two different variables, because now we're talking about he wants to buy snacks for 5 weeks. Very good, Gwen. He wants to buy snacks for 5 weeks. How many weeks can he buy, or no, he wants to buy drinks for 5 weeks. How many weeks can he buy snacks with his remaining amount of money? So you would use that same equation of 45 is equal to 625 snack plus 250 D. And what are we going to do with that 5? Plug it in where? And to the 2.5D. Good. So we would say like 2.5 times 5 plus 625 25s is equal to 45. And I'm not going to do that out because that is simple sort of arithmetic and getting your, so you would multiply first, you would get, I have this written down, 250 times 5 is 15. Subtract it from each side. 30 is equal to 6.25s. Divide it out. How many weeks? He can do, oh my goodness. It was 4.8 when you do the division. So how many weeks can he buy snacks for? In the context of the story, 4.8 weeks. Is there a point, Max?
I was going to ask, how did you get 15? Because what I was thinking in my head was, if you do 0.5 times 5, you would still get 0.5 at the end of.
Oh, you're right. Did I type that in wrong? Let me try it. Thank you for catching that. 2.5 times 5. Oh, Mr. Main. 12.5. I wrote it down wrong. Sorry, guys. You get, Mr. Main. 12. Ooh, that's the wrong one. 12.5 minus 12.5. Good catch there, Max. That was good. That was logic. That's a math detective move. So you would get 45. I was wondering why that wasn't going in evenly. 12.5 is 32.5 is equal to 6.25s divided by 6.25 divided by 6.25. I still get 5.2. I buy snacks for 5.2 weeks. No? Ian, what do you think? Good. Yes. Okay. So let me just give me 1 second, Connor. So 5 weeks. Okay. So listen closely. On Monday, I'm starting with question number 20, going through question number 20. So this afternoon, I'm running a session that I'm going to be recording, where I'm going to be going through 12 to 19. It's not going to take long. It's going to take probably 15 minutes to go through the rest of this stuff because it's quick. But I am going to be running a session this afternoon. If you have to come for your quiz, it's going to be recorded and you can watch it later. Like I said, the review session is probably going to go for 15 to 20 minutes tops, and then you'll be free to go. If you come to finish your quiz, that's okay. I'm going to record it. You can watch it this weekend or next week before the midterm. Go ahead.
Is this going to be uploaded too?
This is going to be uploaded as well, yes. With like obviously all the writing and stuff, so you can go back and look at it. This is going to be uploaded at the end of class. You can head out to Spanish if you have Spanish. Friends at home, please send me emails if you need assistance. If you don't go to Spanish, you need to stay. Okay, so awesome job today, guys. Nice job, Ian. Okay, I'm going to stop my share. Oh no, was I sharing? Yes, I was sharing because now it's over here. That's scary. Stop my share. I'm going to